Have you ever thought about how satellites just stay up there, circling the Earth? They don't float, and they're not attached to anything, so what keeps them from crashing down? Today, we're diving deep into the science behind this amazing feat that makes modern life possible. Think GPS, weather forecasting, and even your satellite TV. To understand why satellites stay in orbit, let's start with a simple question. What if we could throw a ball so hard that instead of coming down, it would just keep going around the Earth? Imagine standing on a tall mountain and throwing a ball. If you throw it lightly, gravity pulls it right back down. But if you could throw it faster, much faster, the ball would travel further before hitting the ground. Now, if you threw it at just the right speed, it would essentially keep falling around the Earth in a curved path without hitting the surface. This is essentially how satellites orbit. Now, let's dive into the physics. Gravity is constantly pulling satellites toward Earth, but because they're moving forward at an incredible speed, about 28,000 kilometers per hour, 17,500 miles per hour, they keep missing the ground. This speed is crucial. Too slow, and the satellite would fall back to Earth. Too fast, and it would escape Earth's gravity altogether. It's a careful balance, like a cosmic dance, where gravity is the partner that keeps satellites in this endless loop. And here's something even more fascinating. Because they're moving along this curve in a constant state of free fall, astronauts inside the International Space Station, for example, experience weightlessness. It's not that gravity is gone. They're just moving in sync with it, creating that floating sensation. Let's look at some real-world applications of satellites in different orbits, like geostationary satellites. These satellites are positioned at a specific distance from Earth, about 35,786 kilometers or 22,236 miles, and orbit at the same rate that Earth rotates, so they appear fixed over a single spot on Earth's surface. This is perfect for things like weather satellites and communication satellites. It's almost like they're hovering in space, but they're actually in constant motion around Earth. On the other hand, low Earth orbit (LEO) satellites, like those used in the Starlink network for high-speed internet, orbit much closer, around 160-2,000 kilometers above Earth. They zoom around the planet in around 90 minutes, making them ideal for imaging and global coverage applications but requiring a network of satellites to provide continuous service. To make this clear, imagine Earth as a spinning ball, and satellites orbiting around it like marbles moving along invisible tracks. These tracks are orbits, and the height and speed of a satellite's track depend on what it's meant to do. Higher orbits mean slower speeds, and lower orbits require higher speeds. It's a balance between altitude, speed, and purpose. Next time you're tracking a storm, navigating with GPS, or just catching your favorite show on satellite TV, remember, satellites don't just float, they're locked in a finely tuned dance, balancing speed and gravity to stay in orbit. And there's so much more. What about satellites that actually fall out of orbit? Or even those that get sent way out into deep space, beyond Earth's gravity? Stay tuned as we dive even deeper into these questions on our channel. Don't forget to like, subscribe, and turn on notifications, so you never miss a new exploration.